Oh yeah, I'm about to drop some particle physics in the club. The LHC is super duper fly. You know what I'm saying. Check it. 27 kilometers of tunnel underground, designed with mind to send protons around. A circle that crosses through Switzerland and France. 16 nations contribute to scientific advance. Two beams of protons swing round through the ring they ride, till in the heart of the detectors they make to collide, and all energy packed in such a tiny bit of room becomes mass particles created from the vacuum. And then LHCb's is where the antimatter's gone. Alice looks at collisions of lead ions. CMS and Atlas are two of a kind. They're looking for whatever new particles they can find. The LHC accelerates the protons in the lead, and the things that it discovers will rock you in the head. We see asteroids, planets, stars galore. We know a black hole resides at its galaxy core. But even all that matter cannot explain what holes are. They start together, something else remains. This dark matter interacts only through gravity. How do you catch a particle? There's nowhere to see. Take it back. The conservation of energy, and the particles appear clear as can be. You see particles flying in jets this way, but you notice there ain't nothing going the other way. You say my law has just been violated. That don't make sense. There's gotta be another particle to make this balance, and it might be dark matter. And for the first time, we catch a glimpse of what was the most of the known verse, because LHCb's is where the antimatter's gone. Alice looks at collisions of lead ions. CMS and Atlas are two of a kind. They're looking for whatever new particles they can find. The antimatter is sort of like matter's evil twin, because except for charge and handedness of spin, they're the same for the particle and its anti-self. But you can't store an antiparticle on any shelf, because when it meets its normal twin, they both annihilate. Matter turns to energy, and then it dissipates. When matter is created from energy, which is exactly what they'll do in the LHC, you get matter and antimatter in equal parts. And they try to take this back to when the universe starts, the Big Bang. Back when all the matter exploded, but the amount of antimatter was somehow eroded. Because when you look around, you see that matter abounds, but the antimatter is nowhere to be found. That's why LHCb's is where the antimatter's gone. Alice looks at collisions of lead ions. CMS and Atlas are two of a kind. They're looking for whatever new particles they can find. The LHC accelerates the protons in the lead, and the things that it discovers will rock you in the head. The Higgs, that's the one that everybody talks about, and it's the one sure thing that this machine will sort out, because if the Higgs exists, they ought to see it right away, and if it doesn't, the scientists will finally say there is no Higgs. We need new physics to account for why things have mass. Something in our standard model went awry. Now the Higgs, I still haven't said just what it does. They suppose the particles have mass because there is this Higgs field that extends through all space, and so particles slow down while other particles race straight through like the photon. It has no mass. Something heavy like the top quark is dragging it. And the Higgs is a boson that carries a force and makes particles take order from the field that is its source that detects it. When LHCb's is where the antimatter's gone, Alice looks at collisions of lead ions. CMS and Alice are two of a kind. They're looking for whatever new particles they can find. LHC accelerates the protons in the lead, and the things that it discovers will rock you in the head. Now, some of you may think that gravity is strong, because when you fall off your bicycle, it don't take long until you hit the earth and you say, dang, that hurt. But if you think that force is powerful, you're wrong. Now, you see, gravity is weaker than weak, and the reason why is something many scientists seek. Now think about dimensions. We live in just 3, but maybe there are others that are too small to see, and it's into these dimensions that gravity extends, which makes it seem weaker here on our end. But if you are as tiny as a graviton, you could enter these dimensions and go wandering on, and they'd find you. When LHCb's is where the antimatter's gone, Alice looks at collisions of lead ions. CMS and Atlas are two of a kind. They're looking for whatever new particles they can find. The LHC accelerates the protons in the lead, and the things that it discovers will rock you in the head. Oh yeah. Our understanding of the universe is about to change thanks to the Large Hadron Collider. This is P to the A to the S to the C to the A to the L, coming at you straight out of Aberdeen. Mr. P dropping the beats.